Let's take a look at this acid-base question. HBr reacts with zinc hydroxide according to the following balanced equation. So zinc hydroxide plus 2HBr gives you ZnBr2 plus 2H2O. An unknown quantity of zinc hydroxide is reacted with 90 centimeters cubed of HBr in a flask. Assume that the volume of the solution does not change during the reaction. The excess HBr is then neutralized by 16.5 cm cubed of NaOH of concentration 0.5 moles per dm cubed. The balanced equation for the reaction is, so HBr plus NaOH gives us NaBr plus H2O. So the question reads, calculate the pH of the HBr solution remaining in the flask after the reaction with the zinc hydroxide. So let's just to take a look at what's going on here. So we have a flask, right? And that's approximately 90 centimeters cubed of HBr. And into this, we are adding in some amount of zinc hydroxide. Now, there's going to be some left over, right? They tell us that there's excess HBr. So this is the leftover, right? Now, this leftover is going to affect the pH, right? And it's going to have some concentration, right? But then what they've done is, with the leftover, they reacted it with NaOH. And so if we want to work out the pH, we need to work backward to figure out how much was left over, then convert that to a concentration, and then calculate the pH. So let's start with the second reaction. So you have the HBr plus the NaOH giving you the NaBr plus H2O. So if you look at the NaOH, the information that we're given the volume, which is 0,0165 dm cubed. So converting that from cm cubed to dm cubed. Then we also given the concentration, which is 0.5 moles per dm cubed. Now we can calculate the number of moles. Number of moles is equal to C times V, 0.5 times 0,0165, and that gives you 0,00825 moles of NaOH. Now, if we have to take a look at the mole ratio between the NaOH and the HBr, the mole ratio is 1 to 1. So therefore, we can say that we had 0,00825 moles of HBr that reacted. And this is the excess amount. This is the leftover. Now what we need to do is we need to convert that to a concentration, right? So we'll take that 0,00825, and to get it into concentration, remember we can calculate concentration by saying concentration is equal to number of moles divided by volume. So 0,00825 divided by the volume that this leftover is in. It's in 90 cm cubed. So we'll convert that to dm cubed. That's going to be 0,09 dm cubed. That gives us a concentration of 0,092 moles per dm cubed. So now that we have the concentration, we can calculate the pH. But before we calculate the pH, we must work out the concentration of the hydronium ions. Because remember, pH is equal to minus log of the concentration of the hydronium ions. We've got the concentration of HBr that was in excess. So we need to look at the dissociation of HBr. So HBr will dissociate. So you could react it with water. Let's do that. And when it reacts with water, it's going to donate a hydrogen because it's an acid. So you'll get H3O plus Br minus. Now what we're interested in is the H3O plus. the ratio between the HBr and the H3O plus, this is a balanced equation, is 1 to 1. So therefore, the concentration of the H3O plus is going to be the same as the concentration of the HBr. So now that we know the concentration of the H3O plus, we can calculate the pH. So pH is going to equal minus log, and the concentration is 0,092, and that's equal to 1,04. Now let's take a look at the next question. Calculate the mass of zinc hydroxide initially present in the flask if the initial concentration of HBr was 0,45 moles per dm cubed. Okay, so let's look at our information again. So now we have HBr, and this is at the beginning now. We know the volume is 0,09, and they now give us the concentration, which is 0,45. We can calculate the number of moles, and number of moles is equal to C times V. That's going to be 0,45 times 0,09. That gives us 0,0405 moles of HBr. Now remember, this is at the beginning, right? And from this 0,045 moles, there was the excess amount. And we had the excess amount. It was 0,00825. That means the amount that reacted with the zinc hydroxide must be 0,045 minus 0,00825, and that's 0,03225. Now that we know the number of moles of HBr that actually reacted with the zinc hydroxide, we can use a mole ratio to figure out the number of moles of zinc hydroxide that reacted. So we go to our reaction and we look at here. The ratio between HBr to zinc hydroxide is 2 to 1. So if we know that 0,03225 moles of HBr reacted, if we divide this by 2, we'll get the number of moles of zinc hydroxide that reacted. So the moles of zinc hydroxide is going to be 0,03225 divided by 2, because again the mole ratio was 2 to 1 or 1 to 2, and that's equal to 0,016125, and this is the moles of zinc hydroxide that reacted. Now that we know the number of moles of zinc hydroxide and we know the molar mass of zinc hydroxide, we can calculate the mass. So the final step would be the mass of zinc hydroxide that was used in this reaction is going to equal the number of moles times the molar mass. The molar mass we get from our periodic table. So number of moles is 0,016125 times, and the molar mass is 99. And that's equal to 1,596 grams of zinc hydroxide at the beginning. Again, thanks so much for watching. Don't forget to like, share, and subscribe. Until the next one.